Let us discuss outlier detection and outlier handling. So before going for that, let me discuss what are the types of outliers. The first type is known as the global outlier. So what is a global outlier? So here the object significantly deviates from the rest of the data set. Next one is a contextual outlier. What is a contextual outlier? Object deviates significantly based on a selected context. For example, say 28 degrees centigrade is an outlier of a Moscow winter, but it is not an outlier in another context, that is say 28 degrees centigrade is not an outlier for Moscow summer. So that is a contextual outlier. Last one is a collective outlier. So a subset of data objects collectively deviate significantly from the whole data set, and even if the individual data objects may not be the outliers, for example, say a large set of transactions of the same stock among a small party in a short period of time can be considered as an evidence of market manipulation. So in this way, we are having three different types of outliers: global outliers, contextual outliers, and collective outliers. So let us go for the coding now. So here we have imported the respective modules, and here we have created one data frame with three attributes: price, bedrooms, and size. The data frame name is flat, that is a house or a flat I'm considering. So here we are going for the respective printing. So I'm executing this. So here is my data frame. Consider the last record. Here the prices are all of 5-digit numbers, but it is of they are of 6-digit numbers, and it is of 7-digit number. So here the bedrooms, all of them are lesser than 10, or you can consider 20 also, but it is 125. I think it is a very big compared to the rest of this. So that is a global outliers we can consider. Next one, here all the sizes are 4 digits, but here the size is of 5 digits. So here we are having some outlier. So one record, at least I'm finding that it is containing some outlier values. So now how to detect it? So the method we are showing here is the elliptic envelope. Assumes that the data is normally distributed, and based on the assumption draws an ellipse around the data, and classifying any observation inside the ellipse as an inlier labeled as 1, and any observation outside the ellipse will be labeled as outliers and labeled as -1. A major limitation of this approach is the need to specify a contamination parameter, which is the proportion of observations that are outliers and the value we don't know. Here we are considering that this contamination parameter, here we are considering as that 10% data will be outliers, but here it is very difficult to guess it. If we know that 10% data is outliers, so I think we are having a good concept on the data set, but that might not be always available. So this elliptic envelope, this particular method is having some limitations for that. So here we are defining one outlier underscore detector object under the class elliptic envelope. Contamination parameter I have passed as 10%, that is a 0.1. Fit detector, so executing the fit method and also the predict method. You can find that here it is being labeled as 111. So this 4 records, it has been considered as non-outliers, that is the inliers, and the last record has been considered and labeled as -1. It has been treated as outliers. So next one is that how to deal with them. So at first we can go for the drop. So here we are using one formula, one condition, that is if the bedroom size is less than 20, then it is okay. Other than it is, the record has to be dropped. So if we execute the same, you can find that the last record, the last row has been dropped because its size was 125, which is greater than 20. You can easily find it out here. It is 125.0. Okay, next one, the mark. That means I do not want to delete, but I want to mark it with 0 and 1. So here we can go for, that is when the flat bedroom is less than 20, mark it as 0, otherwise mark it as 1, and I'm creating another column. There is a flat outlier. So now you can find that this column has got filled up with the values zeros and ones, and zeros have been put against those rows where the flat size is here you can find that the bedroom size is less than about 20, but whenever the bedroom size is greater than 20, I'm finding this one has been labeled as 1 according to the given code. Next one is the rescaling. So here we are creating one new column head, that is a log of square feet. So the log of square feet is there. So here is a, we are taking the x, we are taking the x, log of the x, and then x is the respective flat size. So on the flat size, that means on this very column, you have done this log and you have done the scaling to some extent. So now you have, if you print the respective data frame, it is getting printed one extra column, that is the log of square feet. So now let me go for the, that is the IQR, that is that is the intermediate quartile range. So here you can find that flat is equal to df. So df, I'm just keeping, I kept this df earlier also, so that I want to work on the original data frame. So df is this one. So now I've kept this original value there in df. So now here we are having this interquartile range. So IQR, interquartile range. So the flat has been initialized with the old values. So those two extra columns have got deleted now. And then we are calculating the quartile 1 and quartile 3. We know that quartile 1 means 25% data will be below that value, and quartile 2 means the median, that is a 50% data will be below that value, and quartile 3, that is a 75% data will be below that value. So flat dot quartile, quantile, that is a 0.25. So we are calculating the quartile 1 and we are calculating the quartile 2. The method name is quantile, and that is your 0.25 and 0.75 I have passed. So interquartile range, so here we can find this one as Q3 minus Q1. There is a IQR, print IQR. So I'm printing this value here. You can find that if you print this IQR, I'm finding that the IQR values for price, bedroom and size, so they are this. So now when Q1 minus 1.5 into IQR and Q1 plus 1.5 into IQR, so any flat whose corresponding value is less than this or greater than this will be considered as the respective outlier. So it has been treated as any axis is equal to 1. So this condition will be applied column wise, and then flat out will be the new data frame. You can find that the last record has got deleted. So here you can find that we are putting this one as not. That means those records which will not be satisfying both these two conditions will be persisting, and those records which will be satisfying any one of the conditions will be deleted. And so the third row has got deleted from here. So this is my total code here. You can also type the code, you can do the respective experiments on it to have the better understanding that how to detect and how to deal with the outliers and what are the different types of outliers. We have discussed that one into details. Thanks for watching this.